All right. Okay, so we're continuing chapter 5. We are talking about ionic compounds and molecular compounds here today. So if you could look in your textbook on page 169, that's where these notes are found. I'll zoom in a little bit. So you'll have to jot down some of the notes that I highlight.
This screen's broken.
There we go. How's that? Better?
Yeah.
Okay. Okay, so two types of compounds. Now, what we learned yesterday, and we watched that video yesterday, we filled out the blank sheet yesterday. What we learned yesterday is that everything is made up of atoms and molecules. All matter is made up of atoms and molecules. Atoms would be the smallest sort of pieces of any element that you see on the periodic table. And when you combine those elements, you get things called compounds. Now, there are two types of compounds. Very important. The first type is called an ionic compound. So this word is ionic. You want to write that down as a title there in your notes. Ionic compound. And I'm going to just clip this into the notes here briefly. Okay, so an ionic compound. Common table salt is familiar to most people as a white substance composed of tiny little crystals. Table salt forms when a very reactive metal, that's sodium, combines with a poisonous yellow-green nonmetal, which is chlorine gas. Now, as we just discussed at the beginning of the class here, when you're talking about table salt, you're not taking your life into your own hands every time you sprinkle salt on your supper meal. Don't worry about that. But sodium by itself is very reactive. You drop a chunk of sodium in the water, and it'll fizz, and it'll jump around, and might even light on fire. It's very, very reactive. However, once it gets into a compound, the characteristics change a lot. Just like chlorine. By itself, chlorine gas is poisonous. But in a compound, the characteristics can change quite a bit. So sodium chloride, so you got ionic compounds, right? That's your title, okay? So sodium chloride, or NaCl, is an ionic compound. And the properties are very different from the individual elements. So sodium chloride is an ionic compound. You write that down. The chemical formula, as you see here, is NaCl. It's a chemically combined compound. Atoms are chemically attracted to one another and bonded to one another. Okay? So why is it ionic? Well, you should know, or you might know, that this, a charged atom, Na plus 1 charge, and this, chlorine minus 1 charge, these are ions. Ions. And because they come together, because of their opposite charges, the positive and negative, and they're attracted to one another and they bond, that is called an ionic compound. So it's because of the opposite charges, positive and negative, that these compounds are made. That's what makes them ionic. Okay, so what is it about ionic compounds? So what should we know about ionic compounds? Well, they are pure substances usually consisting of one metal, and one non-metal. So a metal atom or element, like sodium is our example, sodium, and one non-metal, like chlorine, make ionic compounds. And if we look at the periodic table, so ionic compounds, one metal, one non-metal usually. Where's a picture of my periodic table here? Maybe not there. Give me one sec. So periodic table, so if you notice, and some periodic tables, the one in the back of your textbook there, is on page, your Pearson, Saskatchewan 9 textbooks we're working off of here. Can you guys see that? Find that? Where is it? Yeah, right at the very back. Really, it's the last thing. So 436 and 7, maybe, is that what it is? Or 486? What is that? 486. Okay. So, yeah, it kind of does give you an indication here by the different colors that the metals are basically this right here with kind of this a little staircase here that are, so these are the metals here, okay, these ones here, those are the metals. So basically the kind of the middle and the left side of the periodic table. The non-metals would generally be over here. These are the non-metals. And the ones kind of on this little staircase, some of these ones are kind of like caught halfway between. They have properties of both. But certainly anything over here, like this right here,
That hydrogen is.
those are metals. Metals. And these ones here, on this side here, kind of here, these are non-metals. And you know what? I see sodium right here, and I see chlorine right here. So a metal and a non-metal. Those what's most ionic compounds are metals and non-metals. Metals form positive ions. Non-metals form negative ions. So yeah, so it was mentioned that hydrogen, I've got hydrogen technically in my little circle here. Hydrogen is very special. Notice that in this periodic table, it's there and it's over here. Hydrogen, let's just say hydrogen's special. It's not a metal or a non-metal. Okay, hydrogen's one of those real special ones. But generally, the ones that form positive ions here can be treated as metals. The one that form negative ions over here, non-metals. Okay? Okay, good. There's lots to talk about with the periodic table. There's lots to talk about bonding, so that's great. We're just kind of getting into the basics here. So what about ionic compounds? What you could write down? They have high melting points. So high melting points for ionic compounds. They don't like to they like to stay solid. So they have a high temperature boiling melting point. They don't like to be liquids. They like to be solids at room temperature. You have to get them pretty hot to melt them. They form crystals. They dissolve in water pretty easily. So they dissolve in water pretty easily. And they conduct electricity. So this is what you're copying down. I'll give you a moment to do that. And of course, they're solids at room temperature. So you can copy down those 4 things about ionic. Okay, so forming ionic compounds. When elements combine to form an ionic compound, an atom of a group of atoms loses or gains an electron to form an ion. So let's copy this down. An ion, okay, is an atom that loses or gains electrons. Okay, let's make that a simple definition of ion. An atom that gains or loses electrons. Now an ion could be made of more than one atom. That's why we have the group in there. But let's just say an ion is an atom that gains or loses electrons. So it forms a particle called an ion that has an electric charge. So if you gain electrons, that means you're getting more and more negative pieces, right? More and more negative particles. So the ion is charged and its overall would be a negative charge. If an atom loses electrons, that means it doesn't have as much negative character anymore, so it becomes positive. It's positive. Okay? So when a positive ion and a negative ion get together and form a compound, it's neutral. So an ionic compound, like sodium chloride, is neutral because the positive and the negatives balance each other out. So most ionic compounds are neutral. Okay, they end up to be no charge. No overall electric charge. Positive and negatives are equal. So just want to jot those down in your notes. Okay. If you need to shut these lights off, you guys at the back, if you can't see, go ahead. So as we continue here, these diagrams right here, I think this is maybe the first time we've actually talked about this. These are Bohr diagrams. We're gonna practice making Bohr diagrams for elements here soon. But the Bohr diagram shows, okay, it shows the nucleus in a little picture. And you remember back, let's see, I can go back here. You remember the Bohr model there? There's the nucleus, and these rings represent sort of the energy levels where the electrons kind of hang out, right? And so this is a Bohr model of a sodium atom. Now, what happens to the sodium atom is that one of its electrons, and that's this guy right here, you see how it's kind of on the outside ring. So it's kind of like lonely and cold out there on the outside ring all by itself. And what happens is it's like, it wants to jump over to another compound if possible, because look at, there's like other electrons on the outer ring, so it doesn't feel all alone. Now, sodium ions do not have feelings, but that's the way I'm kind of trying to get you to think about it. So when sodium has one electron on the outermost ring, because there's no room for it inside on the inner rings, then that electron has a tendency to want to jump off of that outside ring. And so that's why sodium, when it loses this electron, here's the electron and it goes somewhere else, sodium becomes positive. Because you've got a big positive charge here, and now you don't have enough negatives to balance off with this charge. So then it becomes overall a little bit more positive. So sodium actually has 11 protons, and if you count these little dots, 2 in the first ring, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, so 8 in the next ring, and then here this is the 11th one, so 11 protons, 11 electrons. If this goes away, this 11th electron, if it goes away over here, then it only has 10 electrons now. 11 pluses and 10 minuses. That gives us an overall charge of +1, you see? Now what happens to the chlorine when it takes on sodium's electron? Well, chlorine, if you look on the periodic table, it's number 17. So the positive charges here, there's 17 positive charges for chlorine. A chlorine atom also has 17 electrons, but when it takes on one more electron, what happens is this becomes 18 electrons, so it now becomes a negative ion. So there it's got 18. If you counted all of these dots, there would now be 18 of them. Okay? So that's what happens. Sodium, chlorine, they come close to each other. The electron jumps over here, and then boom, now one's positive, one's negative, and they get sucked together, and their bond, a positive and negative, attracts. Okay?
Wait, so
yep.
electrons are the ones that are flying around the nucleus?
Electrons fly around the nucleus. That's right. And so here's what happens. So here's the diagram. You see there's one electron that's now missing from sodium, so it's positive, and one electron that's added to chlorine, which makes it now negative.
It's like a stick.
Yeah. Okay, so just a little bit more about ions. There's lots to learn. I would focus on this part though, a polyatomic ion. So there are ions that are made of one element, like sodium ion, chlorine ion, like we've talked about here above. But there are also polyatomic ions. Poly means more than one. Poly, more than one. And atomic would be atom. So more than one atom can form an ion. For example, in this compound, this is a sodium hydrogen carbonate or sodium bicarbonate compound. The sodium ion is made of one type of element, just sodium, but the other ion is made of three different elements. This is the polyatomic ion. So polyatomic ion would be made of more than one kind of atom. So where is that? Groups of atoms can act as a single ion. There you go. A polyatomic ion. Groups of atoms acting as a single ion, like this right here. So you want to put that in your notes there. So the other type of compound we've talked about ionic. We're going to talk about molecular compounds now. Molecular compounds. These are compounds formed by two nonmetals. So if you have elements from the right side of the periodic table, so again, compounds formed by two nonmetals, and here's our periodic table, and the right side of the table here are the nonmetals, right? So if you have something like carbon dioxide, you may have heard of that one, or carbon tetrachloride, that's another one, nitrogen dioxide, sulfur dioxide, okay, that silicon dioxide. These ones where we have elements from this sort of section of the table combining with each other, those are molecular compounds. And it's not because they form ions, because the ions that these would form would all be negative. So negative does not attract to negative. Negative and negative do not form a bond. Only negatives and positives form a compound. So it's not because of the charges. Okay, so when two nonmetals, and again, we should add that it's not because of ionic charges. So compounds formed by two nonmetals, not because of opposite ion charges. And examples, as I mentioned here, so examples would be something like carbon dioxide. Okay, you could have diphosphorus pentaoxide, things like this, sulfur trioxide, let's say. So those kind of things where the elements are both coming from that sort of right side of the table there. Chemical formulas. Okay, what's a chemical formula? Well, a chemical formula would be, it identifies the elements and how many elements are in the compound. So literally, H2O is a chemical formula. It's a formula for saying how many atoms and of which elements are in a compound. H2O, NaCl. These are chemical formulas for compounds. All right? Now, there are subscripts here, these little numbers here, right? That indicates how many of these elements that there are in the compound. So for water, we see that H2O means that there are literally 2 hydrogens and 1 oxygen. Okay, the diagram, oxygen atoms are super huge compared to hydrogen atoms, so they would be kind of bonded, like this. Here's hydrogen, hydrogen, and then oxygen. And technically there would be a little bit of an angle on this. Let me just draw that a little more accurately. Okay, so that's oxygen, these are hydrogen, hydrogen. So 2 hydrogens for 1 oxygen. And in NaCl, because there's no subscript shown, it's 1 Na atom with 1 Cl atom, or ion. Okay? All right, so when we were drawing those ions, do you remember we were drawing the ions that had the circle, nucleus, and then the rings like this right here? These are called Bohr diagrams for ions. These are called Bohr diagrams. So what we're going to do is we're going to do a little activity here, a little assignment where you're going to actually draw the Bohr diagrams for the first, looks like 18 elements. So on the paper that I handed out to you here, okay, there's a little space, and what I want you to do is I want you to do this. I want you to draw a circle, and I want you to put the number inside the circle of how many protons there would be in there. So for example, hydrogen is number 1 on the periodic table, so there's 1 proton in there. All right? Now, how many electrons would be in a neutral hydrogen atom? 1, right, because there's 1 positive, so we need to have 1 electron. So you would draw the ring, and you would draw 1 sort of dot on that ring somewhere on the ring. Doesn't matter where. And you only need to draw the first ring, because that's the only ring that has electrons in it. Yep.
Could be for like helium, draw the circle and put 2,
You're catching on. You're catching on. Helium, draw your little nucleus. How many protons? 2. Now, what we have to remember is that in the first ring, there can only be 2 electrons. Where you put them, it doesn't really matter. There can only be a maximum of 2. Helium has exactly 2 electrons, so they fill up the first ring. All right, now I'm going to skip down. I'm going to skip down to neon here, okay? So let's do neon. How many protons in neon? What's the number? It's 10, so you put a 10 in there. Now we have to fit 10 electrons in rings around the nucleus. So in the first ring, how many electrons can I have? 2. There's 1, there's 2. You can put them beside each other or across from each other. They're both negatively charged, so they would kind of want to stay away from each other as much as possible. So I always put them on the opposite sides, but it doesn't matter. So then the next ring, guess what? The next ring can fit 8.
What?
Yeah. So you might want to write this down if you want. First ring around the nucleus, 2 electrons. And that's my little symbol for electrons. If you're in my science class again, you'll see me write electrons like this. E with a little negative exponent and an S. The second ring, can have 8 electrons. There's just a little more space on that ring. And then we're going to need a third ring. I guess I'll write that as a word. Third ring can have another 8 electrons. Okay, so always 2 on the first, then 8 on the next 2 after that. So neon has 10, so I need 8 more electrons. So guess what? I'm gonna fill up this ring. 2, 3, 4, 5, 6, 7, 8. They don't have to be perfectly spaced, but you need 8 on there somewhere. So then you count up all the dots in the rings, and they need to equal the number that's in the nucleus. So the electrons, negative particles, would exactly equal the protons, the positive particles. That makes them a neutral atom. Okay, let's do one more. Let's do silicon. Silicon. All right, that's number 14 on your periodic table. 1, 4 goes in the middle there, 14. And I'm going to put electrons on the rings around the nucleus. So I'm going to put 2 here on the first ring. That's technically filled. So I'm going to go to the second ring. And I can put up to 8. Should I fill the second ring with all 8? Yeah, because 8 and 2 is only 10, so I need 14, so I can go 8 for sure. So 1, 2, 3, 4, 5, 6, 7, 8. Now a third ring, I can put up to 8 in the third ring. But how many? I only need 4 more, don't I? I have 2 and then I have 8, so I have 10 in total. I need 4 more, so I'm going to put 1, 2, 3, 4. And like I say, I spread them all around. You can put them in groups of 2. That's acceptable as well. Okay? You'll have to kind of just kind of use a pretty. You have to sharpen your pencil maybe on this one to get all this in, but you can do it. So take your time. You have a few minutes of class left to work on that. Your only homework for tonight would be to continue working on this and any textbook questions that you haven't completed that I've given you so far. Okay? So that is the end of this lesson. Please continue to work on this assignment until the bell. Any questions?
Where's